All right, good afternoon and welcome to Master Talker online class. Today we'll be talking about a topic that is called function. Function, okay? Before we talk about function, we'll be talking about some definition. Let's talk about some definitions. The first definition we'll talk about is ordered pair. Ordered pair. Ordered pair. Now, how do you know that a pair is ordered? A pair is ordered when you have something like this. Maybe you have A comma B. Okay? A comma B can be an ordered pair if an element of A, that A comes from an element of A and B comes from from a set B. Sorry, A is an element of set A and B is an element of what? Set B. Where A and B are non-empty sets. Okay, an ordered pair is when you bring any first item you are bringing comes from A, okay, and the second item comes from B, then you say that that pair is ordered. Sometimes it can be this way: B and what? And A. It means any first item you are getting from, you are taking it from where? From B, and then the second one comes from what? A. You now say that what? That it is an ordered pair. So the next thing you will talk about is cross product, or cross product. We call it cross. Okay, cross product of sets. Okay, for example, let me show you what I mean by that. Let me say set A is equal to A, B, C. Okay, and the set B is equal to 1, 2, 3, 4. Okay, now and they say you should find A cross B. Okay, A cross B is a set of ordered pairs of these two things. So it means the first person I'm taking from A, okay, then combine it with what? 1. Okay, the next one is what? The same A combined with what? 2. The same A combined with what? 3. You see the one I'm picking? The first person is coming from here, then merge it with other people. Then next one is what? A and what? 4. Okay, the next one is what? B. I'm going to the next person because I'm done with this. B and 1, B and 2, B and 3, B and 4, B and 5. Okay, sorry, not B and 5, but C and 1, C and 1. Okay, C and 2, C and 3, C and 4. So this is called A cross B. But if it is B cross A, it means that the other pair now will not be what? That the first element I'm taking will come from A, will come from B, while the second element comes from what? A. So it's as good as saying the inverse. Okay, the inverse of the relation. Okay, so now the relationship now is called this cross. This cross is the relationship between these two, or we can call it the relation. Okay, the relation now is the cross. So we say that we are taking the first element 1 with A, 1 with what? B, 1 with C. I'm done here with 1. 2 with A, 2B, 2C, 3A, 3B, 3C, 4A, 4B, and 4C. Okay, so that is how to do what? Cross products. Okay, even in set anywhere they say find A cross B. Okay, this is how you take the what? The pairs, the ordered pairs. Okay, so why that cross in the middle is the relation. Okay, if I say find A intersection B, that intersection is the relation. What is the relationship between them? The relation is what is that binding force between them. So that is what is called a relation. Okay, now the next one we are going to talk about is now a function. What do you mean by a function? A function is simply, do I call it a relation whereby a particular element of A, okay, gives a particular result, gives a result that's a particular element of B. Okay, so let me explain by an example so you understand what I am saying by that. But before then, let me show you another thing. They can say that maybe another example before we talk about function. We are still in a relation. Okay, another example, they say that x is equal to the set of 2, 4, 6, 8, 10, 12. Okay, and they say that y is the set of 3 and 4. Then I say that the relation that I want to be between them should be multiple of. So now let's find a relation y, x relation y. So what does it mean? Any element you pick from here, okay, must be a multiple of the next one you are picking from here. And you know that multiple means the bigger one. 6 is a multiple of 3, and 3 is a factor of 6. So if you call the big one first, it will be multiple of the small one. But if you are calling the small one first, it will be the what? The factor of the bigger one. So the only big number here is 4, and 4 is a multiple of what? Of 2. So okay, so let's go now. Sorry, I'm taking the first element, I'm taking it from 6. So if I say 2 is small, 4 is small. Is 4 a multiple of 4? 4 times 1 is 4. So 4 is a multiple of 4. So I'm having 4 and 4. Okay. So the next one is 6. Is 6 a multiple of 3? Yes. So I have 6 and what? 3. The next big one is what? 8. Is 8 a multiple of 3? No, 8 cannot. 8, but 8 is a multiple of 4. The next one is 10. Is 10 a multiple of this? No. The next one is 12. Is 12 a multiple of 4? Yes. But is 12 a multiple of 3? Yes. And 12 a multiple of 4? Yes. Because 4 times something can give you 12, and 3 times something can give you 12. So this is what? A R relation y. But let's go to y now. Relation x. Okay, y relation x. Remember, we are starting from the big one. 3 is bigger than 2, but 3 is not a multiple of 2. 4 is bigger than 2. Is 4 a multiple of 2? Yes. So I'm taking 4 and 2. 4 and 4, correct. 4 and 4. Is there any other thing? No. So this is the result of this. As simple as that. So the next one we are going to talk about, so that is how to do relation. They will tell you what the relation is, and then you find it yourself. So let's do the geometric aspect of it. Let's take the geometric aspect of relation, then we'll move. The geometric aspect of relation. So maybe I'm having this. I'm having 1, 2, and 3. Then here I'm having A, B, C, D, E, and F. Okay, so I have that A relates to what? To B, and they say that and they now draw this. They now draw that A relates to this, and the same one relates to. So the next one, this to this. Number 3. 3 to B, and 3 to C. Okay, I have 4 here. And 4 to F. So let us do this. And here is the relation. So to find A relation B here is what? A relation B here is what? That 1 produces what? A. Okay. And the same 1 produced D. What again? 2 produce A. 3 produce B. And 4 produce what? F. 4 produce F. Okay. So as simple as that. As simple as that. That is that. Okay. So that is for relation. Now let's go to the inverse relation. Inverse relation is like going back. Like if I want to find the inverse relation of this, A inverse relation of B is for me to go back, which is I'll write A before 1, I'll write D before 1, I'll now write A before 2, I'll write B before 3, then what? F before 4. So you are going back. The inverse relation means going back. Okay, that is that. So the next one we'll talk about is what is function. Function is simply when one element of A here relates to only one element of B. That is when it's called a function. So this is not a function because one element of A here is relating to 2. Are you getting it? So function means whenever one element of A is relating to what? Just one element of what? B. That is when you call it what? A function, or a transformation, or an operation. Okay, so it is called a transformation or operation when one element of what? A here, or a member of A here is related to A and B, so that a member of A here produces what? Just one element or member of B. That is when we call it a function. Let's take an example to that. Example will be helping us. Example will be helping us. So look at an example. An example said that what? I have A to be 0, 1, 2, 3, and minus 6. And B is equal to, and B is equal to Y, okay, which is an element of a real number, such that f of x is equal to y, which is equal to x squared, and x are elements of A. Okay, so we want to get this. To get this simple, let's get all the members of B. So all the members, the first thing I'm saying is f of x. So let's start from A. Okay, you know they said that what? That any element you are picking to do this thing, that f of x is equal to you getting y, and which is equal to x squared. They have given you the formula to use, and they say that any element you are picking, that x is picking element from A. So let's start picking. So the first one is f of 0, which is equal to what? 0 squared, which is what? 0. The next element is what? F of 1, which is what? 1 squared, which is 1. The next one is what? F of 2, which is what? 2 squared, which is 4. F of 3, which is what? 3 squared, which is what? 9. The next one is what? F of minus 6, which is what? Minus 6 all squared, which is what? 36. So B now is equal to the set of 0, 1, 4, 9, 36. You see that for each element of this produces just one element of what? One unique element of B. So this is a function. This is a function. So any element you pick here is producing a unique element of B. That is when you call it a function. The definition does not really matter. Okay, where it matters is when you look at the product, you see that okay, this thing produces one unique element here, so it is a function. Because there is a question that they will ask you, is this thing a function or not? So let us do. I'm supposed to draw the geometry aspect of it, but let's use this one. That A is equal to a set of 0, 1, 2, 3, and minus 6. Okay, the same thing. And B is a set of f of x, which is equal to x squared minus x, such that x is an element of A. Okay, so which means they've given us the formula f of x, which is what? X squared minus x. So the thing we'll do is what? F of 0 will give us 0 squared minus 0, which is what? 0. The next one, f of 1 is giving us 1 squared minus 1, which is what? 0 again. The next one, f of 2 is giving us 2 squared minus 2, which is what? 4 minus 2, which is 2. The next one is giving us f of 3, which is what? 3 squared minus 3, which is what? 9 minus 3 is 6. The next one is f of minus 6, which is what? Minus 6 all squared minus 6, which is what? 36 minus 6 is 30. So for B is what? 0, 0, 2, 6, 30. So that is that, okay? So to represent it now, let us represent it. Let us represent it. To represent it, I'm having what? 0. This is for A. 0, 1, 2, 3, and minus 6. For B, I'm having what? 0, 2, 6, 30. So I'm having that 0 produces 0, and 1 produces 0 as well. Now 2 produces what? This produces this. Okay, 2 equally produced 2, and 3 produce 6, and this produces it. Now if you look at this is a function because one element here is producing what? It's not producing two people. It's producing just one unique element from here. 0 produces one unique element, which is 0. 1 produces one unique element, which is 0. Okay, they are not producing two things. It's as good as saying 6 produces 30 and equally produce 6. Okay, so this is equally what? A function, and not just an ordinary relation, but a function. So this is the geometric representation of that. Okay. So in a simple short form, we say that what? Many to 1 is a function, but 1 to many is not a function. Look at it now. Many people now to 1, you can say is a function, correct? But 1 person to many people is not a function. So note, many to 1 is a function, but 1 to many is not a function. So you need to note that. Many to 1, many people to 1 is a function. But whenever the result is giving you 1 person and not more than 1 person, you refer it what? As a function. Okay? So the next thing we'll talk about is domain, range, primitive, and ancestor. Domain, range, and codomain. Okay? Now, let me explain. Domain is the collection of the material you want to use to produce something. Okay? Domain is the collection of the material you want to use to produce something. Now, if you bring out each of the materials without putting it in a collection, without collecting them, each of them is called what? A primitive. Please note, when it is inside a set, you collect it, you call it what? Domain. But if you did not put it inside a set, you call it what? Primitive. Now, when you now put it inside a function or a relation or anything to produce something, then all those things that it produced, if you bring them together and put it inside a set, you collect them, it is called a range. Okay? But if you did not put it inside a set, it is called an image or ancestors. So the primitive men produced our ancestors. Don't forget, the primitive men produced what? Our ancestors. So domain, for example, now if I have this, let me use a diagram to show you that. This is A, B, C, D, producing 1, 2, 3, 4, 5. For example, this produce this, maybe this produce this, this produce this, and this produce. For example, now this is A and B, okay, and they are being related with R. Look at elements of A in a bracket like this, in a set A, B, C, and D. Inside the set is called the domain. Inside the set, you call it what? The domain. But when they are not inside of a set, for example, A, B, C, and D, or you bring anyone you like, okay, you did not put them inside the set, you call them what? It's called what? Primitive. Okay, it's called primitives. If it's one, primitive. Now the next one is, what did they produce? They produced okay, Okay, let me say B, the set of B. The set of B, which is 1, 2, 3, 4, and 5. These one are the possible things they are supposed to produce, not the ones they produce. The possible things they are supposed to produce is called the codomain. The possible things they are supposed to produce is called what? The codomain. So codomain, so range is a subset of codomain. So the one they produced is now the range. Please know the difference. The possibility, you know that these things are possible. The possibility is what? Are the things they are supposed to produce. These are the possibilities of things they can produce. So those things that you think they can produce is called what? The codomain. The codomain. Now the ones they produce themselves, putting them in a set, the one that is useful. In fact, let's call it the useful and non-useful. Okay, it's called the codomain. Why the only ones they produce is now the range. Now, if you did not put range inside a set, you call them ancestors or image. Please note this, very very important. The first thing is what? Domain. Domain is the collection of what? The material you want to use to work. Okay, that is called what? The domain. Now if you did not the domain, if you did not collect them, you did not put them inside a set, you call it what? Primitive. Now when you now put them inside that thing you want to put them into, and then it now produce something, every possible thing you think they can produce, not the one they have already produced though, the one you think they can produce is called what? Codomain, the collection of it. Okay, so now the one they now produced after the process is called what? The range, if you put them in set. But if you do not put them in set, you call it what? The primitive, the ancestors, or what? Or image. Okay, so let me give an example to that so you will understand what we are saying. Okay. Okay, look at this. Look at this. Okay, let's use that example that we used them. We say that that A is equal to a set of 0, 1, 2, 3, in fact, let me use -3 and 6. Okay, and they say that B is a set of f of x such that which is equal to x squared minus 3, x squared minus 3, okay, x squared minus 3, and the x is an element of A. Let's get this. Okay, now look at this. Now if we have this, you will now see that what? The domain is the set of A, which is what? 0, 1, 2, -3, and 6. These are the things I want to use and work. These are the things I want to use and what? And work. Okay, in fact, let me say that this is a set of let me say integers such that which is equal to f of x, which is equal to this okay, let me put it this way. Let me put it that B is what? A set of what? X, which is an element of A. Okay, let me say which is an element of A. Okay, such that f of x. Let me use the exact question there. I don't want to make mistake. I want to use the exact question here. They say that f is equal to y, okay, which is an element of a real number, okay, such that f of x, okay, is equal to what? I like this. F of x is equal to y, which is equal to what? X squared, comma, and x is an element of what? A. I love this. I love this. Now, the domain is what I want to use and work, which is this. Okay, now the primitive is The domain that you did not put in a set is called the primitives. Are you getting that now? So the next one now is the range. Let's get the range and the codomain. Now the codomain is the possibility of things you can get. And they said that y is an element of real number. So anything I'm getting is a real number. So the collection of everything I think I can get is real number. So the codomain here is the real number. Now the domain is now the answer we got. So now let's get our b. Our b is equal to 0 squared 0, 1 squared 1, 2 squared 4, minus 3 squared 9, and 6 squared 16. So now you see that my range is now my answer, which is what? 0, 1, 4, 9, and 16. Are you seeing that now? So now the image now, the image is what? When I did not put image or ancestor. The image or ancestor is now 0, 1, 4, 9, and 16 without putting them inside a set. That is your ancestor. Is this thing a function? Yes, it's a function. Why is it a function? Because each element here did not produce more than one. It produces just one single element. Then it is a function. But when that is 1 to 1. In fact, 1 to 1 is a function. Many to 1 is a function. As far as the end part is just 1, that is a function. So now, but we now have types of function. Now let's talk about the types of function we have. Okay, the types of function. The first type of function we are going to talk about is the identity function. Identity function. Types of function. Number one, the first type of function is identity. Now, if you remember identical twins, that is how you remember identity function. Identical twins means they look alike. Okay? You are like me. You produce exactly the same thing as me. That is when you say that a function is what? Identical, or identity function. Identity function is whereby the primitive is exactly as the ancestor. That is when you say that what? This is an identity function. For every primitive you get, produce the same thing as the ancestor. So look at what I mean by that. If I have a set like this is A, okay, and A is what? A, B, C, D, and E. Producing the same thing again. A, fat C, B, D, E, and D. But I know that E produces E. D will produce D. I just want to turn it around so that in case they want to confuse you in exam, and then you see that this, if you look at this now, this is B. You see that A produces the same thing as A, B produces the same thing as B, the same thing. Whenever you produce the same thing, you are called what? Identity function. So that is that. The next function is what? Constant function. Constant. Now, constant function means where in fact, if all the primitives produce just one single ancestor, then it is called a constant. Constant means you don't change. You are the same. Do anything you like. Change anything. In fact, change the material, you are producing the same thing. It's as good as when somebody wants to build block. In fact, carry ordinary sand and put inside the molding thing, you are getting a block. Put cement, you are getting a block. Anything, you are getting the same block. So when you get the same thing, a constant thing, that is when you call it a constant function. Look at an example to that. Then I'm using this. I'll still use calculation, solving problems. Okay, and everybody is producing. Maybe I have 1, 2, 3, and 4, and this person produces 1. This still produce 1. This still produce 1. This still produce 1. So if everybody is producing the same one, it mustn't be 1. No, it can be 2. It can be 3. It can be 4. It can be A. Okay, when everybody is producing the same thing, that is when you call it what? A constant function. The next function is 1 to 1. From the name itself, you will understand that. The next function is what? 1 to 1. 1 to 1 means 1 to 1 means, in fact, everybody is producing a unique thing. Don't produce what I produced. That is 1 to 1. Okay, don't produce what I produced is 1 to 1. Look at it. For example, I have this. In fact, let me do it from here. Maybe 1 produces this, B produces this, and this produces this, this produces this. See, everybody is producing just one thing, one unique thing. That is when we call it 1 to 1. So one person cannot produce two things. Okay, 1 to 1, and the two people cannot produce one thing. That is 1 to 1. And are you now seeing that 1 to 1 for any what's the first one we did? The first one we did is identity function. You see that every identity function is equally 1 to 1. Let's check it out. Every identity function is equally 1 to 1, because identity, you look like me. If it is A will produce just A. B cannot go and produce A again. B will produce B. So, and they are just producing one single thing. So every identity function is equally what? 1 to 1. Yes, every identity function is equally 1 to 1. Okay. Every identity function is equally 1 to 1. Okay, let me give you okay, when I'm done, let me give you the last one. The last one is onto. Now, onto function is the one that sounds different. Every other one sounds, from the name you will know it, but onto, UNTO, onto function. Onto function means that, in fact, how do you know onto function? Onto function means that the codomain is equal to the range. Okay? What do I mean by the codomain being equal to range? Codomain being equal to range is that, you know that codomain means every possible thing you think it can produce. Now, if you think that this thing can produce 5 things, you listed, I think, if I try this, I am going to get any of these 5 things. And after doing it, you still get that, you still see that they produce the same 5 things. Then you call that function what? Onto function. Whenever the codomain is equal to the range, whenever you have that the codomain is equal to the what? The range. That is when you say that the function is what? Is an onto function. Look at this. The possible things I think this thing can produce is 1, 2, 3, 4, and they still produce 1, 2, 3, 4. So it is what? It is what? An onto function as well. But if I put 5 here and that 5 did not work, this is no longer onto, because the codomain is no longer equal to the range. So whenever the codomain is equal to the range, then that you now call that function what? An onto function. Please, let's list it again. The first one is what? Identity. Remember it from identity element. Identical twins. You must produce the same thing like you. Then that is when it becomes identity. The next one is what? 1 to 1. One person producing one thing. 1 to 1. From the name you will know. The next one is constant function. Constant means the same thing. Everybody is producing that same thing. That is when we know that is what is a constant. Then the last one is onto, which is the one that the name doesn't sound very well. So onto means that the codomain must be equal to the what? The range. Onto you. Okay. Let me give some examples. They say that let D of F be equal to set of 0, 1, minus 5, 6, and 8. Okay? And they say that okay? And they say that they said define F such that D of F maps B by F of X is equal to 2x. Okay, we want to do this. Let's get B. If we are getting B, we are seeing that what? B is what? 2 times 0, 0. 2 times 1, 2. 2 times minus 5 minus 10, 2 times 6 12, 2 times 8 16. So I'm having this. Now, can you call this function one to one? Yes, because one person is producing one thing, one person is producing one thing, one to one is correct. Can you call it identity? No, only this and this are identity, but since every other one is not identity, it is not an identity function. Do you call it a constant function? No, because they didn't produce one single thing, so it is not a constant function. Can you call it an onto function? Okay, you can call it an onto function because they didn't tell us the possible things we are to produce. So let's now think that the possible thing to produce is still the same b. That is when it can be called the onto function. So the domain here is this set. Okay, the primitive here is what? Removing the set. The image is what? Removing the set of this b. The codomain is the b, and the range is equally the b. The ancestor is removing the set of b. Okay, so that is that. Okay, we'll solve one question from past question, then I think we'll be done with that. And okay, I think in our next class we'll solve one question and go over to the next thing. Thank you very much for watching.